Hello everyone. So today I'm here to present you the recap for the last week's lesson. As we know that the last week we discussed about magnetism. So it's a great time we are together here to have a recap. So let's start with that. So as you can see on my screen here, magnetism, we discussed a lot about the magnetism in the last lessons. So let's start with the first slide. Here we go. So as we discussed about what is a magnet, okay boys, so magnets are a special type of material which we use for different purposes in different components of electrical devices also. So first of all we need to go through what is a magnet, the definition for it. As we know, magnets are materials that can be magnetic, and it is having an effect which we can create magnetic effect for different purposes. Especially you can see a horseshoe magnet on the screen. And even magnetic ability can be described as anything which exerts force. It can be on magnet or other magnetic materials. So as you can see, there is a horseshoe magnet on the screen where you can see there is a nut and bolt is getting attracted towards a horseshoe magnet because it has got the magnetic capacity. So let's go to the different types of magnets. As you can see, the first one is going to be the permanent magnet, or else we can call it as a hard magnet. So here in this case of permanent magnet, we can describe it as a material which can keeps its magnetic property even when it is not close to other magnets. So of course these are the main group of magnets in which has a high amount of magnetic capacity it has. Example can be a lodestone containing magnetite is the best example for a magnetic material which has got a heavy magnetic property. So the second one is going to be the temporary magnet. As we know, it says soft magnets. This also can be used to create a magnetic effect in different electrical purposes. So in the case of temporary magnet, it acts as a magnetic only material, and if it is having a magnetic field produced by a permanent magnet or an electric current. So either we have to provide the temporary magnet with either a electric current or else a permanent magnet in order to create a temporary magnetic effect on these soft magnets. That's it, and let's go to the next page. Here we go with elements that can be magnetic. We have some ferromagnetic materials here, as you can see on the screen. Iron is there, cobalt is there, nickel. All they looks a bit silvery in color, but it has got magnetic properties, and these are the metals we derive it from the earth and by mining. Okay, so let's go through some of the important magnetic materials. First of all, you know what is Fe stands for iron. It's a soft iron which loses magnetism very easily, but iron is one of the most commonly used ferromagnetic material by human beings. And the second one is going to be cobalt, and it is used to harden tools. It's famous for hardening property, and this is also a ferromagnetic material. The third one is going to be nickel. Nickel is also a ferromagnetic material which can be used to make jewelries. So it is, because as you can see on the screen, it is having a very shiny property. That's why. And other magnets we have discussed about compass. It is used by people, those who go for sailing, and people those who travel on the land. They go for trekking in the forest. They use compass to find out the directions most commonly. So compass itself, it's the best example for a magnet. Of course, the earth, the whole earth together, the planet earth is the best example for a magnet. So we had gone through some of the most common magnetic field effect of earth in the last lesson. So we will come back to magnetic field effect later in the coming lesson. Once we come to the properties of magnets, this is the major things we discussed and we spend more time on these properties of magnets in the last class. So here the first thing comes to mind is they have a lined up atoms in it, because of course we know if it is having magnetic properties, there are atoms playing a great role inside the material. They have a polarity, as we know that there is a north and south poles which is written as N and S on the magnet. Especially when you see a horseshoe magnet or bar magnet, you can see there are two poles written with letters S and N. So that shows that they are having polarity. And there is no magnets with just one pole, because if we take a magnet, we break it into 1,000 pieces, each 1,000 pieces will have two poles, so they will get a polarity of north and south poles. Okay, so magnetic poles cannot be isolated as well. As you can see on the screen, there is an animation showing the like poles repel. For example, north and north pole of a bar magnet, you can see here, it is getting repelled, and south pole of a bar magnet is getting repelled. So you have to keep it in mind. If it is the poles are going to be same, it is going to repel. So this is one of the key takeaway from the last lesson we had it together. And another animation you can see here, what happens if you keep the opposite poles? If opposite poles are there together, it is going to get attracted. Example, north and south pole of a bar magnet is the best example. If you are allowing it to keep it together, it's going to attract and attach each other. That is what the magnetism is all about. Okay, so let's wind up, and I am here to say a big thank you to all of you for listening to me, and see you guys, and let's continue with the other topics in the next class.